My name is William Jensen, and this is my code walkthrough for PA1 Part B. We're going to start off the walkthrough here in main.cpp. This is our main thread of execution, and this is where we're going to create the kill thread, file thread, coordinator thread, and playback thread objects, and then launch those threads. These objects are going to be initiated with some shared values, including the kill flag. This kill flag is just going to be a wrapped promise and future that we're going to use to check whether or not a thread should be exited or not. For the file thread and coordinator thread, we're also going to pass this shared status of the file buffer. We're going to create that here, initiate it to empty, and pass it to both of those so it can coordinate the access and state of the file thread's buffer. The playback thread is going to receive a kill command that's just wrapped as a generic command. This allows the playback thread to, once all files have been loaded and all audio data has been played, initiate that kill signal, which will end all the threads. We're also going to pass the coordinator thread's input queue, so it can pass along the fill commands to the coordinator thread. So let's start off by going to the file thread. So the file thread, has pretty much one job, and that job is to fill its buffer with data from the headerless WAV files. So it's going to check this status, that shared status that we passed in earlier. If its buffer is empty, then it's going to go ahead and fill that buffer, and then set its status to ready, and make sure to do this conditional variable.notify to send that data on over to the coordinator thread to begin emptying it. The other state we have here is if we have already read all the files, then we're going to trigger this status done, and then again notify the coordinator thread. It's worth noting that we put this here in the empty state. That way we know all the files have been loaded and this buffer has been empty, so this file thread is done, has no more work to do. So let's move on over to the coordinator thread. The coordinator thread has a bit more work to do. So it has two buffers, which are at the very start of this the thread. We're going to actually push these into an empty buffers queue. This empty buffers queue, we have a ready buffers queue, and then we have a active buffer. These are all just kind of logic wrappers for these two buffers. That way we can abstract the fill, unfill, transfer logic from the number of buffers we have. If we wanted to, we could very easily instead add 100 buffers and push all those buffers to the empty buffers right here before the rest of the thread gets started. And that would work perfectly. It wouldn't have to change any of our logic. So in the main loop, we're going to try to push chunks of our filled buffers into the wave threads based on fill commands that we have coming into our input queue, which is that input queue is this circular queue right here, and that's what we shared with the playback thread earlier. The other work here is to take data from the file buffer and put it into our buffers. So we're going to make sure we lock the file buffer status. We're going to do a conditional variable wait for here because we have other work we could do and we don't want to be locked up here. And then if that status has been set to ready or done, then we're going to, if it's done, we're going to set this local member variable to true, so we can kind of keep track of that done state. We need to continue to pull the file buffer status. And if it's ready, then we're going to start trying to fill one of our buffers. fill one of our buffers. We're going to change one of our empty buffers. Status to, we're going to change the file buffer status to transfer while we're doing this. Change one of these empty buffers, copy the data in file thread over to the buffer, and then we're going to add that now filled buffer into our ready buffers. And finally, we're going to change that status that we have shared with the file thread to empty. That way the file thread can go ahead and start filling its buffer again. And then the other work we're doing here is pushing chunks. So the main push chunk logic is down here. Up here is logic for handling end state and for exiting early if we don't have an active buffer, and we don't have any ready buffers either, so we don't have any data loaded, and we're just going to exit this push chunk function early. But if we're trying to push a chunk, we're going to make sure our active buffer is filled. If it's empty, we're going to take one from our ready buffers. If it's null, we're going to take one from our ready buffers. Then we're going to try to dequeue one of these fill commands from our input queue and execute that fill using our active buffer. If that active buffer gets totally red, so then we're going to move it to the empty buffers and set our active buffer to null pointer. Since we're passing 2K chunks, not all of the buffer is going to be read in a single fill execution, and that's why we're kind of having to do this red check here. So that fill command is actually executing this fill function on the wave thread. It's still going to be running in the coordinator threads thread, but it's going to be running this wave threads class fill command. If we pass in a null pointer, we're going to take that as indication that there is no more data to be loaded into this wave thread. This wave thread can be considered done, and we're going to notify wave end. This is going to help us coordinate the end of playback state. Otherwise, we're going to try to fill, and we're going to take that input buffer, copy a chunk of it over into our buffer, and then notify loaded. Notify loaded is just letting the wave thread itself know, the thread, know that it has been loaded, the status of this buffer is ready, and it's going to notify and exit. This way we stop the execution that's happening on the coordinator thread as early as possible and leave some work for the wave thread. So the wave thread is going to get that status update. It's going to be responsible for enqueuing that notification to the playback input queue. And that is going to be happening via this notify load command. So I think this is a good spot to move over to the playback thread. The playback thread is responsible for initiating all the wave threads. It's responsible for coordinating them, taking the ones that are empty, sending them to the coordinator thread to be filled, taking the ones that are loaded and sending them to the wave out to be played, and then keeping track of which ones have ended and triggering that kill signal once they have all been ended. So you can kind of see those three different functionalities here broken out into these three different functions. Each of these functions is going to be wrapped up in a command object. That way the wave thread can send a command to trigger one of those functions at any point. And these commands are going to be sent to each of those wave threads when those wave threads are created right here. And this kind of makes our actual loop here in the playback thread quite simple. We're just going to be constantly trying to dequeue from our input queue and executing those commands. We're passing a null pointer because we're using that same command structure used for the fill commands, which required passing a buffer pointer. Here we're just doing an execution. We don't need any pointer to a buffer, so we're going to pass a null pointer for all of these. And that's going to trigger one of these on empty, unloaded, or on wave end states. On loaded, if we're not in a steady state, we're just going to make sure we load all of them. all of the wave threads. Once they're all loaded, then we're going to start playing them and transition into our steady state. Yeah, our steady state means we're just going to constantly enqueue anything that becomes empty into the coordinator input queue to be filled. And it means anytime something is filled, we're going to immediately try to queue that up into that wave out thread. Kind of run out of time here, but the only other things to mention are this the callback. So the callback from the wave out gets triggered. It's going to call notify empty on our wave thread. This is still executing that wave out thread technically, but it's going to call that notify empty. Notify empty is going to update the status to empty, and that will trigger the wave thread loop to enqueue an empty command into the playback input queue. Yeah, and the last thing here is once it receives this onWaveEnd command, the playback thread, it's going to increment the number of threads that are done. Once it knows that all the threads are done, it knows everything has finished playing, and it's going to go ahead and trigger that kill command, and it's going to close out all the threads.